Hi, my name is Shini and today I'll be presenting about paper chromatography. What is chromatography? Chromatography is a technique for separating mixtures into their components in order to analyze, identify, purify, or quantify the mixture or components. We can see in the diagram through an example. It will give you the vision about what chromatography is. So if we put an ink into a sheet of paper or cloth and we make the cloth or paper to make contact with a container filled with water or alcohol in which a complex pigment is dissolved, the capillary action will carry the mixture up the paper or cloth, but the components of the pigment will not travel at the same rates. The uses of chromatography that is used by the scientists, and the first one is to analyze. It is where they examine the mixtures of its components and their relations to one another. The second one is to identify. It means it is to determine the identity of a mixture or components based on known components. The third one is to purify, which means to separate the components in order to isolate one of interest for further studies. The last one is to determine the amount of the mixtures or the components present in the samples, which is called quantify. Here we have an example of a green dye, which will be separated by the blue, which will be separated to blue and yellow, and the blue concentration is more than the yellow after the presence of isopropanol as a solvent. The second example is a red dye, and the red dye will separate to red and yellow, and the yellow has a lower concentration than the red because once again the presence of isopropanol as a solvent. And the alternative experiments. So to test different samples, we can also use other markers, highlighters, pens, flower pigments, food colors, and more. We can also use different alcohols such as methanol, ethanol, propanol, and butanol. We can also test with different papers such as coffee filters, paper towels, cardstock, typing paper, and more. Uses for chromatography in real life situations. The first one is for medical companies that make medicines, and this is to identify or determine the amount of each chemical found in a new product. Second one is hospital to detect the blood or alcohol levels in a patient's bloodstream. The third one is law enforcement, which is to compare a sample found at a crime scene to sample from the suspects. And the fourth one is the environmental agency, which determine the level of pollutants in water supply. And the fifth one and the last one is manufacturing plant, which is to purify chemical needed to make a product. And the more detailed definition of chromatography. And chromatography is a laboratory technique that separates components with the mixtures by using differential affinities of the components for a mobile medium for a stationary observing medium through which they pass. And I'm going to give some definitions. So the differential means showing difference, and affinity means natural attraction or force between things. Mobile medium means gas or liquid that is carried by the component. And the stationary medium is the part of the apparatus that does not move with the sample. Explanation of chromatography. Compound is placed in the stationary phase. Mobile phases through the stationary phase. Mobile phase solubilizes the components. Mobile phase carries the individual components as a certain distance through the stationary phase, depending on their attraction to both of the phases. the illustration of chromatography. So in here, the picture is showing the mixture of dye that is separated from each component, and the blue doesn't have natural attraction of force with the solvent, and this means that the blue is insoluble in their mobile phase. Here we have an animation of a chromatograph. So there will be the colors and they will rise up like this, and they will rise up in different positions, and based on the slide, colors have constituent a component. This color can be decomposed because the stationary phase tends to hold the component of their mixtures and their mobile phase tends to separate the color. So we can conclude that chromatography is a great physical method for separating mixtures and solvent by looking at the different absorption of colors. Types of chromatography. So the first one is liquid chromatography, which is used to separate liquid and gas to separate vaporized samples, and paper basically to separate dried liquid, and thin layer chromatography to separate dried liquid as well. And here we have a picture of some ions, and the large molecule in the solid will be combined with small molecule. That means that it can spread out as mobile phase. Affinity will be there as well. And principles of paper chromatography. First is Calipari action, which is the movement of liquid that have space of proposed material to the force of adhesion, cohesion, and surface tension. The second one is solubility, which is the degree to which material solute dissolved into a solvent. This allows different solute to be separated by different combinations of solvents. RF value. The RF value, or we can call the retardation factor in chromatography, is the ratio of the distance traveled by the center of the spot to the distance traveled by the solvent. Or we can also say that the distance component divided by distance of solvent, and this is the example from the calculation. Distance of the component traveled is 0.1 cm and the distance of the solvent is 2.8 cm. So the RF value will be 2.1 divided by 2.8, which will be 0.75, and the RF value is useful to identify chemicals if they can be compared to range of reference substance. And the RF value doesn't have a unit. Thank you for listening to my program.